Hello everybody, welcome to another video. Hope you're ready to flex those brain muscles. Today we're talking about some more simplifying radical expressions, but this time with variables. So let's go ahead and get right into it with some examples. We'll look at this first example. It may look simple, but there's a reason I'm showing this example, right? Well, we know that the x squared and the square root of x, they kind of cancel each other out. They kind of reverse each other, or however you want to think of it, and this becomes x, right? But there's one little thing. What if we plug in like -2 for x? So basically, what if x is less than 0? Then what happens? We have -2, that gets squared, that becomes +4. And we take the square root of +4, that becomes 2, right? So this becomes 2. Draw a little 2 here. But what about this? This is still -2 because we plugged a -2 in for x. So we're saying 2 equals -2, which is not true. So in other words, this statement is only true when x is positive. What if we want it to be true for all x's? Then we would have to add what? An absolute value here, right? And this isn't always taught in all algebra classes. In fact, I didn't learn this at first when I was first learning this simplification. I learned it a little bit later when I started tutoring this. But it does come up. It depends on the professor you have and the level of algebra you're in and that sort of thing. And if you have never seen this, you can ignore it and that's fine. So let's look at this next example, square root of x to the 4th. This can be rewritten, right? And this is basically just square root of x squared times x squared. So in this case, an x comes out and an x comes out. So basically x squared comes out total. In this case, do we need the absolute value? No, right? Because x squared is always positive, and x to the 4th is always positive, and the square root is always positive. Everything's always positive, so we're good. So in general, what's our rule for when we need absolute values? It's if we have an even root, right? Because there's an invisible 2 out in front of these roots, an invisible 2. So when we have an even root and when an odd power comes out, there's an invisible 1 here, right? So if an x to the 3rd comes out, to the 5th, any kind of odd power comes out of an even root, it needs to have the absolute value around it. But if it's an even power, 2, 4, 6, anything like that, you don't need the absolute value. And also, if this is a third roots are allowed to have negatives, right? So there's no issue there. So if it's an odd root, we're not worried about absolute value. And again, if you've never seen this, if you don't need to know this, you can just close your ears and that's fine too. So let's go ahead and look at this last example, 8x cubed, and let's try to simplify this. Now we have a integer in here as well as a variable. So we're going to do the same process. We're going to break up this 8 into what? 4 times 2, right? Because 4 is a perfect square. And we're going to break up this x cubed. Let's go ahead and do it. So 4 times 2. And this x cubed can be broken into what? X squared times x. So what can we take out here? We could take out the 4 and it comes out and becomes a 2. And we could take out the x squared and it comes out and becomes an x with an absolute value. And what's left in here? We're taking out the 4, we're taking out the x squared. We got 2x left. 2x. And there we go. That is the fully simplified radical. All right, let's go ahead and get to some more examples. So we're trying to break this up so we can pull things out of the radical and simplify this. So the first thing I'm going to do is rewrite this 32. And I want to rewrite this as something, 2 things being multiplied and one of them being a perfect square. So we know our perfect squares, right? 4, 9, 16, 25, 36, right? And I think the 16 will work in this case. We can write this as 16 times 2. And then with the x to the 5th, we can write that as x squared, x, right? Because when we multiply, we add the exponents. 2, 4, 5. There's an invisible 1 there. Times, and this radical is extending here. Y squared. So what can we pull out of here? Anything that's a perfect square, right? So x squared, 16, and y squared can all come out. So what does this equal? The 16 comes out and becomes 4. What else comes out? And x squared comes out and becomes x, but 2 of those come out. So it actually becomes x times x, which is x squared, right? So let's see, this is out, this is out, this is out. And then the y squared comes out and becomes y, right? And because this is an even root and this is an odd power, we technically need a little absolute value around our y. And what's left in here? 2x, right? And there we go. Sorry, the absolute value is a little messy, but That is the final simplified form. Okay, let's go ahead and do a cube root because we haven't done any cube roots yet. So again, we're looking for perfect squares here that we can pull out. And in this case, we're looking for perfect cubes, right? So what do we have? 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. I think that's as far as I can go in my head, but you need to know at least the first 5 perfect cubes, right? So let's look at this. What is this case? Let's see if we can split this up. So 16 is what? 8 times 2, right? Didn't we say 8 was just 2 cubed? 8 times 2, so this is a perfect cubed. And then what? X to the 5th. Instead of splitting this up into x squared, x to the 1st, I'm going to split it up into x cubed, right? Because that's what I'm trying to pull out. I'm trying to pull out something being cubed because it's a cube root. So times x cubed times x squared. And the y is just y, right? So, what does this become? Let's see, our 8 is a perfect cube, right? So that can come out. And that comes out as a 2. And what else? So that's gone. Let's see, x cubed comes out as x. Let's see, what are we left with? 2x squared and y. None of those can be pulled out, right? So what's left in the cube root is just 2 times x squared times y. Do we need the absolute value? No, because this is an odd root, right? Okay, so let's go ahead and do this example. Cubed root of 250 x to the 7th, y to the 6th. So same process. Let's see what we can split this up into. Okay. And you could still use that method where you do a prime factorization on these numbers, where you break this down into a product of a bunch of primes, and instead of circling pairs of numbers, you'll circle sets of 3, right? So if you find like 3 2s, you can circle those and a 2 would come out, kind of thing. And that method I showed in the last video if you want to watch that. So let's see, what is this a product of? 125 times 2. Didn't we say 125 is a perfect cube? 125 times 2. X to the 7th, I'm going to write that as x cubed times x cubed times x. And y to the 6th, I'm going to write that as y cubed times y cubed. Okay, so what's coming out here? And I'm running out of room, so I'm going to write it down here. So the 125 comes out, but it becomes a 5, right? Cube root of 125 is 5. So the 2 stays in, the 125 is gone, the 2 stays in. Both these x cubes come out as x's. So what actually ends up out here is x times x, so x squared. That x stays in. Both these y cubes come out as well, so it comes out as y squared. And what is left in this cube root? Let's see, 2x. I think that's it, 2x. Did I miss anything? Nope, I think that's it. So that is the final form of this. All right, let's do 2 more examples. I'm going to break this up. And I need to see if I can break this up into something where it's the product of 2 numbers and one of those numbers is a perfect square since we have a square root. So let's see. I think 103 will work, right? And that may have taken you a little bit of time to get to, and that's okay if it did. 103 will work because 100, the square root of 100 is 10, right? That's a perfect square. This will work. What about x to the 9th? Well, I'm going to actually do a little shortcut here, and I'm just going to write this as x to the 8th times x, and I'm going to write y to the 7th as y to the 6th times y. And the reason why I'm doing this, and maybe you see why already, is that this is a little shortcut. I can think of this x to the 8th as 4 pairs of x squareds, right? And each x squared comes out as an x. And since I have 4 x squareds, 4 of those x's will come out. That's one way you can think of it. Another way you can think of it is we could use our square root property and we could split this up. And we could say, okay, that x to the 8th part is just square root of x to the 8th, which could be rewritten as x to the 8th to the 1/2 power, which is actually just x to the 4th. So however you want to think about it, if you want to use your exponent rules or if you want to just think of like having pairs of x squareds, however you want to think about it. So this 100 comes out as 10. This x to the 8th comes out as x to the 4th. So that 100, that x to the 8th. Y to the 6th, same idea. That's 3 pairs of x squareds. So y to the 3rd comes out. What are we left with? 3xy in the radical. 3xy. And let's say we had an even root and we have this with an odd power. So we're going to write our absolute value and we're done. Okay, this last example, we have a fourth root, which we have not seen yet. So let's go ahead and do it. And I don't expect you to see many of these in your algebra class just because they can get a little tedious, right? The numbers get really big. But let's go and do this. Do we know our fourth powers? Like 2 to the fourth, what is that? 16. 3 to the fourth is 81. Oh, that's like what we have here, right? 3 to the fourth. So this can actually just go ahead and come out as a 3. This can come out as a 3. What about our x to the 8th? We can use this same idea and we can say, oh, well, this is like x to the 4th times x to the 4th, right? And each x to the 4th comes out as x. So 2 x's would come out in this case, right? X squared. And what about this y to the 4th? Just 1 y would come out. And let's see, we have an even power. This is an odd degree, so we're going to go ahead and put our absolute value there, and we're done. So hopefully this helped. If you have questions, go ahead and comment below. Hit the like button and subscribe if you enjoyed. Keep flexing those brain muscles, and I'll see you in the next video. We'll make some more brain gains.